Okay, so welcome to the movie. You'll find out why I call it a movie in a second, or at the end of the talk you'll know. I have a lot of slides. So I suggest we'll do questions at the end unless you have very brief clarifying questions in between. All right, so first of all, this talk is really kind of condensed experience from the last few years. So everything I'm saying here is actually stuff that we found out sometimes the hard way in customer projects. We did, for example, 3 product definition languages in the insurance domain, 2 languages for calculating benefits in the government area, to non-technical, non-programmers. Here I mean engineers, here I mean people with a tie. And any number of business knowledge and software, that's where we start. So what is business knowledge? I think I like to define it, it's that what makes a business tick and distinguishes any given business from other businesses. It's more than business, these BPMN diagrams. Examples include business rules, all kinds of financial calculations, data structures, mappings, queries, validations, processes. In science, there is a lot of stuff going on when you process data. And of course, also UIs to do all that stuff. So these things are not contributed or should not be contributed by developers. This stuff should be contributed by people who are experts in the domain, but it still needs to be implemented in software. So the big question is, how does it actually get into the software, right? And there are some trends and additional challenges in this space. One is that the complexity of this knowledge, domain knowledge, is getting or is increasing all the time because domains get more complex. Also because of what's called mass customization, where you want to have a special version of whatever you do for a special customer or a special subdomain or a special market. And of course, time to market needs to be shortened. We need to be faster. You know all the story, right? So it becomes an increasing challenge. We have customers where the law changes faster than they were able to adapt their, let's say, systems that deal with the law. And I mean, law isn't known to be fast, right? But it was even faster than what they could do in terms of implementing the system. So there's a problem. So how does this stuff work in reality? Well, there is domain knowledge somewhere in the world, in the company. Then some business people, I use that guy as the business guy and that guy as the developer guy. Some business people try to understand it, make sense of it. Then they typically put it into Word or Excel or some really bad web application. And then this is somehow piped to the developer guy, who tries to understand it and sometimes succeeds, sometimes fails, and then somehow encodes it into software. And obviously it would be much better if it were like this, right? I mean, I think everybody would agree to that goal. If not, then it's a good time to leave because the rest of the talk doesn't make any sense. Huh?
Everyone except the program.
Yeah. And I realize you're all programmers. So, but I mean, the programmers have interesting stuff to do in that context. I'll get back to that at the end. So the idea is to let business and domain people contribute to software directly, and our role as software people is to give them expressive and productive tools to do so. At least that's my opinion. So these tools need to have a notation that's friendly for these people, that they don't perceive as dangerous programming. I'm not a programmer. I can't deal with keywords. They need a great tool or IDE for that. I think these people should be able to test their business logic without getting the software people involved. You should have meaningful analysis in these tools to give them feedback about whether stuff is correct or complete or consistent. And of course, then you want to, in the end, analyze or synthesize the software to make the system run, obviously. Otherwise, it's all relatively pointless. So who is this guy? These slides I've added yesterday morning after the panel on programming and programming languages, because there was always this distinction between real programmers and casual programmers. Like, real programmers know what they do, casual programmers don't really, and so we need to give them other tools. I think it's not about casual or non-casual. It's about that these guys, they don't care about software stuff, meaning performance, scalability, reuse, inheritance, all this fancy stuff that we like to brag about and use. But they understand their domain very well. They are actually professionals. They're not casual anything. They're professionals. They're just not professional software people. So it's not like they come one day and need to program 5 lines of business logic. They spend their whole day, every day, doing this. So they are professionals, and they just don't have the tools to get their thoughts into the software. So in my opinion, the way to address this problem is to use a class of tool called language workbenches, which I'm going to introduce. And then the main part of the talk is actually about lessons learned in this area. So I'm just going to give you a quick glance into how we, I should say, build these kinds of systems, and then we can look at what we've learned. So the idea of getting stuff from the domain expert's head into software is old, right? So you just build a domain-specific language, have a generator, and build the system. Or if you don't want to generate, then you put an interpreter somewhere that reads the program expressed in a suitable language and runs it. So far, so good. Old idea from the 70s. The idea is obvious and nothing special. However, what has changed it started changing in the 70s, but I think it finished changing only relatively recently, in the sense that those tools, these language workbenches, only recently got to a state where you could do the kind of stuff I'm going to show we want to do. So a language workbench is a tool that lets you freely define languages and integrate them, right? It's a term that was introduced by Martin Fowler in 2004 as the killer app for domain-specific languages. And he had a couple of additional criteria for defining language workbenches. I think they're not very useful, and I think he thinks in the meantime they're also not very useful anymore, so he kind of changed his mind there. But this combining and integrating of languages is important, and such a tool should not just allow you editing your programs written in this language or in these languages, but also testing, refactoring, debugging, version control, and a great IDE. This is all stuff that needs to be addressed by such a language workbench. It's not enough if you can define a grammar and give your users VI and say, here's VI and the grammar, go, have fun. It's not enough, especially not for business people, as you'll see. Also, I have this pet peeve that I'm not going to discuss in this talk, but I think programming and modeling is the same thing. It's just you have a language at some abstraction level to express some aspect of your system. Doesn't matter if it's graphical or textual. Doesn't matter if you call it modeling or programming. The point is, such a tool should be able to do all of this, because some things are actually quite low level, algorithmic or math-oriented, which you may want to call programming. And other parts of your domain are more like, for example, data structure definition, which you typically call programming, or process definitions here with activity diagram-like kind of things. And you want to address all of these with this kind of tool. So language workbenches make building languages easier, and they blur the distinction between what's typically called programming and modeling. And there are many language workbenches. There is actually this language workbench competition whose job it is to compare these different language workbenches at languageworkbenches.net. You may want to check them out. I have a particularly favorite one. Like everybody involved in this stuff has a favorite one. And my favorite one is a tool called MPS from JetBrains. It's a language workbench, surprise, surprise. It's open source, Apache 2.0, so it can be used in commercial contexts without any problems. And version 3.2 is current. Version 3.3 is to be released probably this year. It's not so clear. What distinguishes MPS from many other language workbenches, not from all, but from many, is that it's a very comprehensive system in that it doesn't just support definition of language structure and editor and transformations. That's kind of the minimum, right? If you can't edit your programs, and if you can't define meta models, and if you can't transform stuff to other stuff, then there isn't much point to it. But MPS, for example, also is quite sophisticated in terms of defining type systems, things like debugging for your DSLs. Not all language workbenches do that, as you can see in the 2 papers that have been written about the language workbench challenge. It's used by a bunch of companies. It's just name dropping, so let's drop on. What's probably most important in MPS is that even though you may see text on the screen, the text is not parsed, and that's important. So instead of, in a parser-based system, a user changing the concrete syntax, the characters on the screen in the text buffer, and then a parser building a tree, and then everything downstream happens from there, projectional editors work different. They still have a concrete syntax which the user sees and in which you move your cursor around and stuff, but every editing action directly changes the AST. There is no parser. And this is crucial. It also has drawbacks, but I'm not going to talk about them today. Thijs will do that if you just ping him and he'll start. So projectional editing has two advantages. One is that you can deal with all kinds of notations that are not parsable because you don't parse. Okay, so textual stuff, obviously, but also math symbols, tables, and even diagrams with embedded text. And obviously, this is drawn with PowerPoint, but here are a couple of screenshots from Embedder. It's a system where we've extended C with domain-specific extensions over the last few years, and you can see how these different languages, or these different notations, I should say, interact. We have math symbols and C functions, or a table in a C function, or a data model. And in the data model, in the data diagram, you can press Control Space to do code completion or textual stuff, so it's all completely integrated. And that's, of course, one important building block to doing meaningful business applications, because business people don't just want to write stuff like that. In fact, they try to avoid stuff like that as much as possible. So that's an important ingredient. The other important ingredient is that such projectional editors do not have the problem of ambiguity when you compose independently developed languages. And this is a longer discussion, but the point is that instead of having a parser, which when you combine grammars may run into ambiguities and then the parser stops, or you have to write disambiguation code, what a projectional editor does is it just tells the user to disambiguate. And this means that you can combine arbitrarily independently defined languages in one program, and there's never going to be a syntactic problem. In terms of semantics, nobody knows, right? We cannot prove that composing two languages will lead to semantically meaningful stuff. Nobody can, as far as I know. We can't either. But syntactically, it's never a problem, and we've developed over 50 independent extensions to C, and you can use them together in programs. We never encountered problems with combining them. Obviously, we didn't try every 50 with all other 50, because that would be too much. It's part of the problem, right? But we didn't encounter any issues in practice. So projectional editing provides syntactic flexibility and language extensibility, which I think is an important ingredient for these kinds of business languages. There are usability issues with projectional editors, at least historically. And those have been mostly solved. And I'm just going to point you to a paper where we did a survey with students and with professional developers. And after a few hours or days to get used to the editor, people are kind of happy with it. So it's not that they are identical to text editors. There will not be, there cannot be. But the way this editor works is different, but not worse than text editors. I guess that's a good way of putting it. And this is quite different than in the 80s when these tools were first built. The editors were unusable. Anyway, and MPS is, I think, the best one in that space, but there are others. Specifically, you may have heard of Charles Simone, Intentional Software. They do the same stuff, but it's closed source and commercial, and nobody knows what they're doing these days. They're back in secrecy mode. Probably in a few years, they'll bubble up again, have a propaganda initiative, and then go back. It's unclear. Oh, this is recorded, right? Yeah, but it's like this, right? They have had one of these public phases a few years ago at UPSLA in Miami. They had a demo, and now they're back to not saying anything. All right, so let me give you a few examples of languages and notations we use in such business systems, and then we'll go to the lessons learned. So here is a data type definition. And as you can see, it's a kind of a mix between a form, where there are some rigid parts, and then the actual contents. An empty data type definition looks like this. So when the user, the business user, creates new data type, they don't get an empty editor in which they then have to orient themselves and use Control Space to build something. They already get these like form-like structures, and that helps. Guidance helps in this case. And so and you can't delete this stuff, right? That's just rigid skeleton. It's there, and you can only fill code into these various places. That's useful, not for real programmers, but for, in our experience, business people. Here is another nice example where we assign values to this variable based on conditions. We've had an earlier version of this where we had a switch and then a bunch of case keywords, and they rejected it. We're not programmers, we don't want keywords. This makes us sometimes smile, just change it to a vertical bar and they're happy. Strange people. But they're scared by this stuff, and using this notation is, it seems, or it has shown to be more friendly. Here is, do you want to translate? It's Dutch? No. Okay. This is what will pay you the money if software engineering becomes uncool and you get fired, I guess. That's the Dutch tax agency where they use a more or less prose-like expression language to pay out benefits. And they use this kind of stuff. Some business people think that having operators like plus or greater than is hard to read, and they'd rather read is greater than. I don't believe in this, not even for business people, but, well, you can do it if you want to. Here is an example where we use a language, a textual language for data modeling, and there are data entities with attributes and references. And of course, you can press a button and then you can edit the same thing graphically, right? So this ability to change notation depending on your user and switch for a same program to notation is also something that's appreciated. Tables for reference data, right? It's all happening in the same editor. Inside the table, you have code completion for your expressions. Here is an example where we have Word-like comments on the side. These comments in the gutter that Word provides. We've added them to the programming environment so that people can use comments as in Word. Was a big hit. Obviously, you can always do comments with / or something, but they preferred this one. Here is another example that shows mathematical expressions. Many business systems are actually about calculations. If you think about taxes or benefits or insurance, this is all calculations with a bunch of documentation around it. So if you can use direct mathematical symbols, that's a really big win, as opposed to putting everything into 7-bit ASCII linear parents sum I, 0, n, expression. Makes a huge difference. Actually, with this demo alone, we won one of our insurance project contracts because we could do 2-dimensional math expressions as opposed to linear expressions in text. Here is another example, one we built very recently, where for these expressions here, we have tests directly embedded, and then you can see whether tests succeed or fail. I think test-driven insurance contract development should be a thing, right? And this is really an experience. These people want to do this because if they get their rules wrong, the company really loses money. And they don't want to be the person who did that. So simulating a business contract, and I'm expecting your next tweet. The ability to take an example customer and simulate how whatever is paid over his life and just look at this, play through it, change inputs, see how this plays out is really critical. Yeah, that's not so important. Here is a BDD style language for testing stuff. Here is a language where we have very meaningful, as you can see, prose text. That's not important. What is important is that we embed buttons directly inside the editor. So instead of requiring people to press Control Space to add a new comment, they can press the button because that's more explorable. Pressing Control Space is tough for business people initially, in our experience. They don't want to do this. They're not used to it. There are no buttons. So we embed buttons directly in the editor. I've seen that before. Or here, that's another example. That's the C case, but the point is on the right, you can see we have a palette where you can press the various symbols in a text editor-like thing, even as if it were a graphical editor. So this aids explorability, right? Because it shows the things you can do. So these are all experiences that we've made that help with these kinds of tools. Here's another example, prose for describing requirements, but then we embed actual expressions with test cases that are executed and the debugger, which shows the test case and its sub-expressions as a tree overlaid over the concrete syntax. So in other words, this is 200 because it's 10 times 20. This is 20 because this column is activated because those conditions are true and so on. So you can debug expressions directly on the syntax. It's also something we've developed for our first insurance project. So these were the examples. Let's move on to the lessons learned. So the first important thing is that you have to get your users to be precise, right? Not programming, but precision. So let's see what's the difference. I think precision means instead of just writing colorful prose, you actually put some formulas or rules in there with a defined language, data structures, tables, values, stuff like that. This has nothing to do with programming because programming, in my opinion, is about these things I've mentioned before. Scalability, performance, robustness, deployment, security these days, I guess. So you want to get business people to be precise, but not to be programmers. And it's also, by the way, precision is not the same as formalization. Formalization is about Greek letters, analyses, and proofs. That's not what you want them to do. So I like precision better than formalization, even though I use the two terms exchangeably all the time. So how do you, why would you want to be precise? Well, it's obvious. That's the whole point of this talk. You can make changes to your system without waiting for the IT guy to the developer to implement it. You can directly test and debug your business knowledge, and you can play with alternatives, right? That's what business people tell us they do with these kinds of systems. How do you get them to be precise? Well, first of all, you have to make them, they have to be willing to take responsibility, because it's actually quite convenient to write your stuff into a Word document and then give it to a developer. And if the system isn't correct, then you say, well, the developer didn't understand what I said, right? Very convenient. So business people must be willing to be responsible for what they write or program or specify. That's a change. It must have a good fit with the domain. Try a UML diagram and you'll fail, right? I'll have a case study or example of this later. The notations obviously need to be friendly. You need good tools, and you need to educate and train. This is tough, because in my experience, if you go to any prospective customer and try to sell them on an idea, and you tell them that to introduce this idea you actually need to do some training on your people, then they tell you, thank you for your visit, here's the door. Training is not something anybody wants to do for some reason. So that's a problem, but I don't think there's a good alternative. Also, what helps is if the technical people tell or say that it's not their job to implement the 25th, 100th business rule in Java code. It shouldn't be the technical people who do this. And if they just refuse, that helps introduce this stuff. So how are business languages and programming languages different? I already mentioned a couple of things, but one is that business people like more structure, whereas programmers prefer Lisp. 3 language constructs that you combine completely orthogonally, no structure, no guidance, no limits, no restrictions. That's different for business people. They want guidance, at least initially. That's a challenge that this may change. Notation, most programmers are okay with text plus a bunch of tree views, right? For business people, it's different. Guidance, again, that's related to structure, right? Business people prefer more guidance. We actually have a request from one of our customers now that they want on the side, on the screen, they want almost something like Clippy, you've just done this. Do you maybe now want to do this to finish the task? I hate this, right? But that's what people want. I think it's going to be important to provide a button to switch it off again. So when people get annoyed at some point, you can, get rid of it. But yeah, layout. In our experience, there is not going to be a war about whether the curly brace is at the end of the previous line or at the beginning of the new line. There are wars about this here, but not there. So projectional editing is fine here, and there it has a little bit more challenge. Views, most programmers are okay to just have text and one file that contains everything. Well, sure, there may be a front-end JSP or Java program or JavaScript program and then the backend Java stuff. But the point is, experience is that business people want views. For example, we had this inheritance between insurance contracts, and it was important to show or to have a version of the notation where all inherited methods are shown in line in the subcontract so that you don't have to understand inheritance, right? Yeah, they want powerful tools with as many buttons and options as possible. They want clean tools with as few buttons as possible. And this is also important. Developers know that they want to become effective with the tool. So they're willing to take some learning effort because they know that at some point they'll need the power. If you ask business people, they always emphasize learnability, right? Because they haven't done this before. They don't realize that after a few months of using a graphical editor, they would actually be happy to have a text editor because that's faster. So that's a challenge. You somehow need to go from here to there. So these languages are actually quite different from programming languages, and we should therefore also build them in other ways. So what are these kinds of languages? I think they're a hybrid of different worlds, right? There is a bunch of stuff that we take from classical languages and IDEs. I'm not going to read all of them. You can do that while I'm talking. There is stuff we take from modeling tools, this notion of having multiple abstractions or multiple notations. There is stuff we take from applications and forms, rigid structures, more process orientation, like do one step after the other as opposed to getting a blank sheet where you can do whatever you want. Buttons, tree views, visualizations, stuff like that. Wikis, there's stuff we take from wikis, right? The ability to use prose text with embedded links. I don't know why this is getting darker all the time, but it is, right? Okay, so I'm not like losing eyesight. We also take stuff from spreadsheets, this notion of document orientation, or the notion of the visible computation, where the computation happens in the spreadsheet, and when you change something, the rest updates, reactive if you want. Live execution, to have the test directly in the document. That's stuff we know from spreadsheets. So we take from all these various areas and we call the result LOPA, right? Language-oriented business applications. So how do you achieve consistency? That's an important issue, right? You can't have 5 business developers do 5 different things and they don't fit together. And in my opinion, there are 2 different kinds of this consistencies. There's local consistency, which you kind of enforce by having a real language as opposed to just free text. Cross-reference as opposed to just names, modularization and reuse. And then, of course, importantly, automatic derivation. Instead of having 3 artifacts at different abstraction levels, all coded manually, hopefully consistent, you specify it at one level and then you use transformations as much as possible. This is the old code generation idea, right? Nothing special. But that, of course, achieves consistency between these different levels. Global consistency is a bit different, right? You do this typically through version control systems and repositories and periodic global checks and reports. The point is, if you have a really big team, you cannot do all consistency checks in real time in the IDE, because then every IDE would have to load the whole project at the same time. Checking everything in real time won't scale. So you have local consistency in real time as the editor, as the people type, as in any IDE, and then you have a nightly report that checks the various different insurance contracts for global consistency, and sometime there is inconsistencies, and then you send an email to the guys and they need to fix it. I think it's important to keep these 2 separate and address them with different tools. So when you build these languages, what do you have to take into account? Well, obviously you want to build it as you want to orient it and on the domain. That's kind of obvious, otherwise it's not going to work. And you need to build the language in a way that it serves the model purpose. If it doesn't have enough details for code generation, then it's a problem. And there's a conflict between these, right? You may have to put some stuff into the models so that you can analyze or generate, but your domain people may not care about this stuff. And so you can address this by having different views or different separated concerns that you then integrate through references or something. You also have to deal with non-functional stuff like permissions or intellectual property. So you have to, maybe store stuff in different files because one of the files goes to your OEM and the other doesn't. So that's something you need to take into account. Then you need to be able to do all this, right? If your tool doesn't let you compose graphics and text, well, then you have a problem, and I have no solution except get a better tool. The other one is that there is sometimes a mismatch between the way the language is structured and the user skills, right? This is where education helps, and by showing the results in context, meaning, for example, generating reports which then look like the documents they wrote manually before, so they can kind of connect to what they have done here. And finally, there are also software engineering practices. I don't think it's a good idea to create variants of insurance contracts by taking one, copying it with its 500 rules, and then changing 2 of them. It's not good. I'd rather use inheritance or something like that. But business people don't know about this. So there is a real strong problem here. And in my experience, what helps is to let them create the chaotic version first by copying, or at least build them a tool that makes it look as if they would copy, and then use refactorings or clever projections to show them, as if it were copied, but the data structures in the background are really just, not a clone, but an inheritance with 2, copy on write, kind of. This is really important. What else do they have? So the language is not enough, right? You want to start, of course, with a language that fits the domain, but you need, as I said several times, a good IDE. That's probably obvious. But then you also need really good error messages. The end users or domain people will not accept the kinds of error messages we sometimes get from development tools. They need to be better. They need to be much more descriptive. Refactorings. I think refactorings are important so that you can go from one structure of a business plan or of an insurance contract to another one. So refactorings for business data structures is important. And then testing, I think, is essential. I want business people to write their own tests. And finally, this notion of debuggers or animation of execution or simulators, so they can have their data come alive for them and actually play with it. This is crucial. And that's, by the way, quite a bit of work to build tools that can do all of this stuff. So, I mean, it's a bit of work with language workbenches. If you don't use a language workbench and start from scratch, it's not, I mean, it's too much work. So that's why I think language workbenches are the enablers here. So what are some of the requirements on the tool? Well, obviously it needs to be a great language workbench so that it can do all the stuff we talked about. It needs to be productive, support productivity in the sense that we, as the domain changes or understanding of the domain changes, we want to be able to quickly evolve the languages. We don't want the language developers to be the bottleneck now, because that will kill the approach. Fancy idea, but you can't keep up with the business. Bad idea. Performance. Obviously, the tool needs to be fast. Nobody wants to work with a sluggish tool. You want to make it scale for non-trivial sizes. It shouldn't just work for the Hello World insurance contract. Migration support, extremely important. As your language changes, what do you do with existing models that conform to the old version of the language? What do you do with them? You have to pull them along by migrating them. And it needs to be friendly. We underestimated the problem of a tool which, when you press the right mouse click, you have 30 items in the context menu. It's 25 too much. So you have to really cut it down to the essentials. And it needs to be explorable. This notion that you get help, for example, through these palettes or these clippy kind of things. So again, if we go back to the tool itself, of course, is not enough. You need essentially, even though I really hate this word, right? So I mean, put in another word if you know a better one. But there needs to be a process how you work with the tool to actually achieve good results. And there probably need to be some metrics. Is like in the technical space, is an interface with 500 methods a good idea? Probably not. So you need to give feedback. Maybe you want to split this into 2 interfaces. Same thing with insurance contracts or other stuff like that. Yeah. And also somehow, if you have a tool that lets you do formal stuff and prose, it doesn't help if people still only put in the prose. They need to be disciplined enough to actually formalize stuff. So again, this is where you either educate, or where you have, it gets darker again, or where you have features in the tool that lets your users, guide the users. You have used stuff in your prose that looks like it could be formalized. Multiply by, you just check for these words, and then you pop up a warning and say, isn't that maybe a problem that you want to formalize? And maybe you ask this guy, he can help you, right? So does this scale? If that doesn't scale, what else does? I really have no idea how else you could tackle the complexity in these kinds of applications. I really don't know. This is not marketing speak. I just don't know. These are not alternatives that work. We know that. We're too slow. It's too expensive now, right? Also, does the tool scale? Well, it depends, right? Depends on the tool. You obviously have to put some thought into how you structure your system. If you put everything like into one big file, it probably won't scale. So you have to do the usual stuff you do when you do tool support for anything. You have to think about how you make it scale. Team size, sure, it's all version controlled. By the way, you may want to hide the complexity of systems like Git from the end user. They're not going to get it. And in terms of language complexity, yeah, not a problem. We've implemented C. That's worse than any insurance contract language you can imagine. So can the people do this? Yeah. But as I said before, you have to train them. Some people may not get it, and some people may not want it, right? So this is a threat to some people. And things that are threats need to be managed, right? So why is it a threat? Well, because for the business people, it requires new skills or a role change, or they may think I'm going to lose my job because I'm automated, right? Similar for the technical guy. Automation. I don't need to write anymore anything, right? It's going to be automated. I'm going to be fired. Of course, that's not true. But also they may be afraid of this one, right? Business people don't need them anymore every day for all kinds of things. There are people who have a problem with that. So I suggest reading and then using the tips in this book to do this. So it's a cultural change that needs to be managed. And I'm almost finished. So we've tried this before, but it failed. Not going to read those, but a concrete customer tried this with UML and MDA, and they failed. Okay. Not surprising. Another customer tried this in a similar way, but according to their own diagnostics, the tool they used to build these languages just wasn't good enough. They couldn't debug, they couldn't test, they didn't have the expressivity, and so it didn't work. So, well, choose a better tool, right? I mean, it was the right direction, but it was like 10 years ago, tools weren't there. So I guess what I'm saying is, if it didn't work in the past, it may not necessarily be a sign that it may not work today. It may be a sign, it may not be a sign, depending on your organization. So what are some of the counter indications? So if you have no structure in the domain, it's hard. If you can't find the language to define the domain, that's a problem. I've had that experience, and we've canceled the project then. No availability of domain experts. If you can't get the knowledge to put into the language, you have a problem. And often these people who know everything about the domain, they're really important in the business. They have other stuff to do. This is a serious problem, or can be a serious problem. And finally, no resources available, right? So we need to run our actual current project. We can't do any of this. We don't have time. We have no money. Well, then, okay, bad luck. Introducing something like that takes effort. And if an organization hasn't ever used a unit test or a version control system or a CI server in their technical development, then they probably shouldn't tackle language development as the first step. They should probably fix these things first. And I've had all of these things happen, and we either stopped the project or we didn't stop and it failed. How do you introduce this? I think you first have to agree that it's a good idea in general. Then you build a prototype, a small prototype to learn the tool. And then you build something that's real, but not mission critical, right? And you can do that either. I just like to put this picture in because Skunkworks is cool. You should create, in my opinion, an organization that is somewhat separated from the daily chores so that people have time to do this. And you need to staff it with people who are motivated and good communicators, because they have to propagandize the rest of the organization to use this if they're successful. If not, then it's a bad idea. I mean, then this is a problem because they'll also tell everybody that it failed. But let's assume it works. And you can either select one slice of a organization and go all the way through, or something one of my customers does now. They do the whole environment, whole organization, but they start unformalized, and then they become more and more precise over time. This only works if they are really sure that they will formalize over time, because otherwise they're just putting Word into MPS. That's a bad idea. So I'm not totally sold on this approach, but my customer thinks that's what they're going to do. Okay, so last thing here, why is this an initiative by engineers? Well, because business people don't feel the pain. If they're inefficient, doesn't matter. They hire more developers and they code faster, right? At least in many organizations, that is actually the case. Not in all, of course. And business people may not know how to solve the problem. They don't know about language workbenches. So it's obvious that this is an idea that comes from technical people. And by the way, I have customers where the business people approached us and not the customer's technical people. So some business people do understand that something needs to change. All right, summary. Running out of time here a little bit, but this is the same slide as at the beginning, and you can see how I think these things can be addressed. And of course, developers are still required. They build these languages. They become language engineering experts and tool building experts. And of course, they add into the mix, all the technological stuff that goes into the generators when entering business knowledge and running software needs quite a bit of engineering to, put into the runtime architecture. That's also what the technical people do. So next time you build a business app, maybe a language workbench is an alternative. All the stuff I've shown, all the tools I've mentioned, it's all open source. It's a bunch of stuff to read. And here's a bunch of people who worked on it. All right, questions?